Yes, sir. In my first class about the number theory, we discussed about natural numbers, whole numbers, integers, positive integers as well as negative integers also. Then next one is even and odd number. So even numbers and odd numbers. First, even numbers. So as I explained you in the introduction class, even numbers are those numbers which are multiple of 2. Those numbers which are multiple of 2 are called as even numbers, or those numbers which are divisible by 2 are called as even numbers. Right? Yes. See, those numbers which are multiple of 2, okay, multiple of 2 are called even numbers. We can write those numbers which are divisible of 2, either multiple of 2 or divisible of 2. Multiple or divisible of 2. Those numbers which are multiple of 2 or divisible of 2, they are called as even numbers. Yes. Right? They are called as even numbers. See, for example, 8. 8 is an even number because it is divisible with 2 4 times. It is divisible with 2 4 times. So those numbers which are divisible. See, 2 is an even number because it is divisible with 2 1 time, or it is multiple of 2 1 time. 4 is the divisible of 2 2 times, or it is the multiple of 2 2 times. 6 is the divisible of 2 3 times. So, okay, if I divide 6 with 2, I will get 3. Is it not so? Similarly, 6 is the multiple of 2 3 times. Even 8 is the multiple of 2 4 times. 10 is the multiple of 2 4 times. That means all the alternate numbers like 12, 14, 16, 18, etc. All those numbers which are multiple of 2 are those numbers which are divisible by 2, they are called as even numbers up to infinity. Next, odd number. Odd numbers. That means those numbers are numbers which are not multiple of 2, which are not multiple or which are not divisible by 2, they are called as odd numbers. So the only difference is those numbers which are divisible by 2, they are called as even numbers. If they are not divisible by 2, here not divisible by 2 means what? Definitely 1 is divisible by 2. When 1 is divisible by 2, I will get 0.5. 3 is divisible by 2. When it is divided, I will get 1.5. Okay, 5 is also divisible by 2. I will get 2.5. Here the divisible in the sense it should be divisible exactly. When you divide, you should get the natural number. It should be divided exactly, not in the form of decimal. Okay, 6 when I divide with the 2, I will get exactly 3. 7 when I divide it with 2, I will get 3.5. So 3.5 it is in the form of a decimal. So when it is divisible by 2, you should get the exact value. You should not get the answer in the decimal form. So very clear. Now the number show ಒಂದು ವೇಳೆ ಎರಡರಿಂದ ಭಾಗಿಸಲ್ಪಟ್ಟರೆ those numbers which are divisible by 2, ಎರಡರಿಂದ ಡಿವೈಡ್ ಆಗಿರ್ತಕ್ಕಂಥ ನಂಬರ್ಸ್ ಅನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಆಡ್ ನಂಬರ್ ಅಂತ, ಈವನ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ಒಂದು ವೇಳೆ ಎರಡರಿಂದ ಭಾಗಿಸಲ್ಪಡದೇ ಇದ್ರೆ, ದಟ್ ಮೀನ್ಸ್ ದ ನಂಬರ್ಸ್ ವಿಚ್ ಆರ್ ನಾಟ್ divisible by 2, in the sense exactly divisible. All the numbers are divisible by 2, no doubt. But when you divide, you should not get in the form of decimal. You should not get in the form of a decimal. You should get whole number or a natural number. So those numbers are called as odd numbers. Very clear? Number which are divisible by 2 are called as even number, divisible or multiple. Numbers which are not multiple of 2 or not divisible of 2, they are called as odd numbers. Example 1, 3, 5, 7, dash 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 up to infinity. So this is the difference between odd number as well as even number. Yes, please note down. Yes. The next one is prime number as well as composite number. The next one is prime number as well as composite number. You remember always either the prime number or the composite number. It may be prime number or it may be composite number. The values should be greater than 1. It may be prime number or it may be composite number. That we will decide prime number, composite number later. But those values which are greater than 1, okay, values which are greater than 1, okay, are to be considered to decide whether it is a prime number or composite number. Okay, values, that is the natural numbers which are greater than 1, natural numbers which are greater than 1 are considered to say whether the given number is a prime number or a composite number. So by this word, it is very clear that I told that values, natural numbers greater than 1, that means you need to take 2, you need to take 3, you need to take 4, 5, 6, dash 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 up to infinity. I am telling you, listen this word is very very important one. Okay, natural numbers greater than 1, ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರತಕ್ಕಂತ ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ಅನ್ನ ನಾವು ತಗೋಬೇಕು. ಯಾವುದಕ್ಕೆ? ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡೋದಕ್ಕಾಗಲಿ, ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಆಗಲಿ ಡಿಸೈಡ್ ಮಾಡೋದಕ್ಕೆ. ಪ್ರೈಮ್ ನಂಬರ್ ಅಥವಾ in order to decide whether it is a prime number or composite number, you need to take the values greater than 1. That means 1 is neither the prime nor the composite. 1 is neither the prime number nor the composite number. 1 ಅನ್ನ ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತನೂ ಕರೆಯಲ್ಲ, ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಅಂತ ಕರೆಯಲ್ಲ. ನಾನು ಈಗಾಗಲೇ ಹೇಳಿದೆ, ನೀವು ಪ್ರೈಮ್ ನಂಬರ್ ಅಥವಾ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡಬೇಕಾದ್ರೆ, ಪ್ರೈಮ್ ನಂಬರ್ ಅಥವಾ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ನ ಡಿಸೈಡ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್ ವಿಚ್ ಆರ್ ಗ್ರೇಟರ್ ದೆನ್ 1. ಒಂದು ವೇಳೆ 1 ಇನ್ಕ್ಲೂಡ್ ಆಗಿದ್ರೆ ಅವ್ರು ಹೇಳ್ತಾ ಇದ್ರು ಯು ಟೇಕ್ ಓನ್ಲಿ ನ್ಯಾಚುರಲ್ ನಂಬರ್, ಆರ್ ಯು ಟೇಕ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಗ್ರೇಟರ್ ದೆನ್ 0 ಅಂತ ಹೇಳ್ತಾ ಇದ್ರು. ಗ್ರೇಟರ್ ದೆನ್ 1 ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಅಂದ್ರೆ 2, 3, 4 ಅಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ನಮಗೆ ಪ್ರೈಮ್ ನಂಬರು, ಕಾಂಪೋಸಿಟ್ ನಂಬರು ಡಿಸೈಡ್ ಮಾಡೋದಕ್ಕೆ. ಸೊ therefore I can tell that 1 is neither the prime number nor the composite number. It is neither the prime number nor the composite number. Very clear? If you want, you can write the note there. 1 is neither the prime number nor the composite number, because prime number or the composite numbers are decided, okay, the values which are greater than 1. Next, I'll give that note afterwards. See, prime number and composite number. Prime numbers and composite numbers. See, what are prime numbers or what are composite numbers? ಕೆಲವರು some smart what do you call that, some intelligent or smart students, they tell that what is prime number means what, numbers which are not composite they are prime number. What is composite number ಅಂತ ಕೇಳಿದ್ರೆ numbers which are not prime they are composite. Okay, ಹಂಗೆ ಹೇಳೋದು. what is prime number ಅಂದ್ರೆ number which are not what is prime number ಅಂದ್ರೆ numbers which are not composite are called prime number. What is composite number? The numbers which are not prime numbers they are composite number. ಈಗ ಇಂಥ ಹುಡುಗರು ಕೂಡ ಐ ಕೆಮ್ ಅಕ್ರಾಸ್ ಇನ್ ಮೈ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸ್ ಹಂಗೂ ಹೇಳ್ತಾರೆ. ಅವು ಒಂದು ಕಡೆಯಿಂದ ಆಲೋಚನೆ ಮಾಡಿದ್ರೆ ಕರೆಕ್ಟೇ, ಬಟ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ಇಟ್ ಇಸ್ ರಾಂಗ್. ಸೊ ವಾಟ್ ಆರ್ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಮೀನ್ಸ್ ದ ನಂಬರ್ಸ್ ವಿಚ್ ಆರ್ ಡಿವಿಸಿಬಲ್ ಬೈ ಒನ್ ಅಂಡ್ ಇಟ್ ಸೆಲ್ಫ್. ನಂಬರ್ಸ್ ವಿಚ್ ಆರ್ divisible by 1 and itself. It should be divided with 1, it should be divided with itself. For example, 2 is the first prime number. Keep this in the mind. 2 is the first prime number and 2 is the only even prime number. It is the only even prime number. You look all the prime numbers. When you look into all the prime numbers, okay, all prime numbers are odd numbers only except 2. 2 is the first prime number and 2 is the only even prime number. Okay, 2. So 2, I can divide this with 1. Okay, when I divide 2 with 1, I will get 2. When I divide 2 with itself, 2, I will get 1. So 2 I can divide with 1, I can divide with 2. I cannot divide with any other number. I cannot divide with any other number. So 2 is taken as prime number. 3, what I can do? I can divide 3. I can divide 3 with 1. I can divide 3 with itself. Okay, 3 I can divide with 1 and 3 I can divide with itself. So 3 is a prime number. Then if I take 4, I can divide 4 with 1. I can divide 4 with 1. I can divide 4 with 4. Okay, when I divide 4 with 1, I will get 4. When I divide 4 with 4, I will get 1. I can divide 4 with 2 also. Exactly division. Is it not so? I can divide 4 with 2 also. Hence, it is called as composite number. Because what is the prime number definition tells? It should be divided with 1 and itself. Astray. But ಏನಾಯ್ತು? 1 itself already ಇನ್ನೂ ಒಂದು ನಂಬರ್ ಇಂದನೂ ಡಿವೈಡ್ ಆಯಿತು. So hence, it cannot be prime number. It is a composite number. Then you take 5. I'll tell up to 10, that's all. 5. 5 can be what? It can be divided with 1. I will get 5. 5 I can divide with 5. I will get 1. But I can't divide 5 with, after 1, I can't divide 5 with 2. I will not get exactly. No 3, no 4, 5 only. Hence, 5 is the prime number because it is divisible by 1 and itself. So if I take 6 is divisible by 1, 6 is divisible by itself, 6 is also divisible with 2. See, 1 and itself, ಅಷ್ಟೇ ಡಿವೈಡ್ ಆಗಬೇಕು. 1 ಇಂದ ಡಿವೈಡ್ ಆಗಬೇಕು, ಇಲ್ಲ ತನ್ನಿಂದ ತಾನೇ ಡಿವೈಡ್ ಆಗಬೇಕು. ಬಟ್ ಬೇರೆ ನಂಬರಿಂದ ಡಿವೈಡ್ ಆಗಬಾರ್ದು. 6 ಏನಾಯಿತು? 2 ಇಂದ ಡಿವೈಡ್ ಆಯಿತು. 2 ಇಂದ ಡಿವೈಡ್ ಆಗೋದಂದ್ರೆ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಡಿವೈಡೆಡ್ ವಿತ್ 3. Okay, 6 when I divide with 3, I will get 2, I will get 3. When I 6 divide 3 with 6 with 3, I will get 2. So it is divisible by 1, it is divisible by itself, and it is also divisible with other numbers. Hence, it is a composite number. Next, I will take 7. 7 can it be divisible by 1? ಎಲ್ಲ ನಂಬರ್ 1 ಇಂದ ಡಿವೈಡ್ ಆಗ್ತವೆ. 7 cannot be divided with 2 exactly. 7 2 times divide ಮಾಡಿದ್ರೆ 3.5 ಬರುತ್ತೆ. 7 cannot be divided with 3, 2 point something ಬರುತ್ತೆ. 7 cannot be divided with 4, 1 point something ಬರುತ್ತೆ. 7 cannot be divided with 5, again 1.5, 1 point something. 7 cannot be divided with 6, 7 can be divided with 7 itself. So 7 is a prime number. 8 and tell orally. 8 is divisible by 1, 8 is divisible by 8, 8 is divisible by 2, 8 is divisible by 4, hence 8 is a composite number. 9 is divisible by 1, 9 is divisible by 3, 9 is also divisible with 9. So it is divisible, 9 is divisible with 1, with 9, even with 3 also, hence 9 is a composite number. Then 10, we know that 10 is divisible by 1, 10 is divisible by 10, 10 is also divisible with 2, 10 is also divisible with 5, so hence 10 is a composite number. So you keep on 11, 12, 13, 14, 15, 16, yes, as many as you can. And very clearly by this example I can tell definition very clearly that those numbers which are divisible by 1 and itself, they are called as prime numbers. Prime numbers. Those numbers which are divisible by 1 itself and even by other numbers are called as composite numbers. Yes. I hope you can write there. Okay. Prime numbers and composite numbers. Those numbers, on the note, those numbers which are greater than 1, those numbers which are greater than 1 are considered to decide prime number or composite number. To decide prime number or composite number. To decide prime number or composite number. That means those values you should take greater than 1. Yes. Along the note ಬರ್ಕೊಡ್ರಿ. Note NOTE. Note. Yes. Very clearly 1 is neither the prime number nor the composite number. 1 is neither the prime number nor the composite number. Then we'll speak about the definition of prime number. Definition of the prime number. I hope you can take, I think so. Yes, those numbers, I'm telling orally, I write that. Those numbers which are divisible by 1 and itself. Those numbers which are divisible by 1 and itself are called prime numbers. Example, you can write 2, 3, 5, 7, 11, dash up to infinity. Next, composite number. Write down definition of it. Those numbers which are divisible by 1 itself, even with other numbers also, are called composite number. You write 4, 6, 8, 10, dash up to infinity. You can write as many as possible. 4, 6, 8, 9, 10 up to infinity. Yes. After this you have to take one note. After this we can take one note. After this you have to take one note. Consider one note. Note. Take down note. 2 is the only prime number. 2 is the only one prime. Sorry, 2 is only one. 2 is only one even prime number. We have many prime numbers except 2. All are odd numbers only. All prime numbers are odd. So I have written here, see, this is odd number, this is odd number, this is odd number. I will get 11, 11 is also odd number. I will get 13, 13 is also odd number. Okay, I will get 17, 17 is also odd number. Okay, except 19 also I will get, 19 is an odd number, 23 is an odd number. So except 2, all prime numbers are odd numbers only. All prime numbers are odd numbers only except 2. 2 is the only one even prime number. Why I am telling is this one. ಬಹಳ ಸರಿ ಕೆಲವೊಂದು ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ಇದನ್ನ. ಈವನ್ ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಓನ್ಲಿ ಈವನ್ ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಬಹಳ ಜನ ಹುಡುಗರು ತಪ್ಪು ಬರೀತಾರೆ. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ದ ಓನ್ಲಿ ಈವನ್ ಪ್ರೈಮ್ ನಂಬರ್ ಈಸ್ 2. ಎಸ್, and of course it is the first even number. Even number ಒಳಗಡೆ ಫಸ್ಟ್ ಅದೇ, ಅದು ಫಸ್ಟ್ ಕೂಡ ಹೌದು, ಅದು ಓನ್ಲಿ ಈವನ್ ಪ್ರೈಮ್ ನಂಬರ್ ಕೂಡ ಹೌದು. ಎಸ್, it is the first and it is the only even prime number. Yes. After this the next subtopic what you can take is fundamental theorem of arithmetic. Take down fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Fundamental theorem. Yes, fundamental theorem of arithmetic. Yes, arithmetic. Fundamental theorem of arithmetic. So what does the fundamental theorem of arithmetic tells? See, what the fundamental theorem of arithmetic tells is, no, according to the fundamental theorem of arithmetic, this is new for you. According to the fundamental theorem of arithmetic, every composite number, before this I given definition what is composite number, what is prime number. So according to the fundamental theorem of arithmetic, every composite number can be converted into prime numbers. Okay, can be converted into prime numbers, and it is been decomposed unically. Sorry, it can be decomposed unique. Yes. See, according to the fundamental theorem of arithmetic, every composite number can be converted into prime numbers. Okay, this you studied at high school level, is it not so? So finding out the prime factors, is it not so, of a given number by LCM method, by factorization method. Some also will do by tree method anta karitare keloru. See, for example, if I give 32, you are supposed to find the prime numbers. Okay, what you do, you will go with LCM method, is it not so? 2 1s are 6, again 2, 2 4s are, sorry, 2 8s are, again 2, 2 4s are, again 2, 2 2s are, again 2 1s are. So what you write? 32 is equal to 2 into 1 2 3 4 5, 2 into 2 into 2 into 2 into 2. So 32 is equal to what? You write 2 to the power of 5. How do you write 2 to the power of 5? We have a chapter called Law of Indices. We have a chapter called Law of Indices. According to the Law of Indices, we have how many formulas of Law of Indices you know? We have 5 laws. First one is a to the power of m into a to the power of n is equal to a to the power of n plus n. Law of Indices, or few of you have a called chapter called indices, few have a chapter called exponents. So we know that this is called as base. This is called as base, and what we write, this is called as power. It is called power, or it is also called as index. It is also called as index. It is also called as exponents. It is also called as exponents. Yes, it is also called as exponents. Right? So we have studied this one. Is it not so? At high school level. So we have one formula, we have another formula, a to the power of n divided by a to the power of n is equal to a to the power of n minus n. Next we have a formula, a to the power of m whole to the power of n is equal to a to the power of m into n. We have another two formulas called change of base rule. We have another two formulas called change of base rule. So whenever required, I will tell for you, this is more than sufficient. First formula, a to the power of m into a to the power of n is equal to a to the power of m plus n. As we know that if the bases are same, then powers can be added. 2 can be written as 2 to the power of 1. All 2 to the power of 1 I can write. So 2 how many times is there? 1, 2, 3, 4, 5. So 2 to the power of 5. 32 is nothing but 2 to the power of 5. So 32 I have expressed in the form of a prime number to some power. 32 is a composite number. 32 is a composite number. I have expressed this in the form of prime number to some power. So this what we call it as fundamental theorem of arithmetic. This is one method few students will do. I think in few classes this is what by prime factorization method. Still few will do like this also. 32 can be written as 2 16 times. Next 2 8 times. 8 2 4 times. 4 2 times. Okay, this is called tree method also. Okay, but this method generally most of the students will not use, only they will go with the prime factorization method. So this is how we are supposed to be. Yes, take down one example. You take down this example. Okay, take down this example and you write this one. Yes. Yes, here 5 and 7 are the prime numbers and they are the factors of the composite number. Hence this method is called prime factorization method. Prime factorization method. This method is called as prime factorization method, or it is also called as canonical representation. C-A-N-O-N-I-C-A-L. Canonical. It is called as canonical representation. It is also called as canonical representation. Based on this, we will have one more question. Based on this, we have one more question. Again, I will explain. So 35 can be written as 5 into 7, where 5 and 7 both are the prime numbers. Both are the prime numbers and they are the factors of 35. Hence, this method is called as prime factorization method, or it is also called as canonical representation. Canonical representation. So, tomorrow we'll continue further. Yes, sir. Now time is up. Thank you for all.